I'm going through a free masterclass by Eric Bogatin, and I'm sharing what I learn and how I interpret it along the way. These are learning notes, not lessons. Follow along if you're learning too. Bandwidth of measurements. In this section, we are going to talk about the bandwidth of measurement tools and what bandwidth really means when we measure signals in practice. We will start with instruments that work in the frequency domain. A spectrum analyzer measures signals in the frequency domain. For a spectrum analyzer, bandwidth means the highest sine wave frequency that the instrument can accurately measure and represent. In other words, the bandwidth sets the upper limit on the frequency content that the instrument can see. Anything above that limit will either be heavily attenuated or not measured correctly. Now let's switch to measurement tools that operate in the time domain, such as oscilloscopes. For an oscilloscope, bandwidth is defined in a very different way. Instead of being specified as a maximum frequency, the bandwidth of a scope is tied to the fastest rise time it can accurately measure. One common way to determine the bandwidth of a scope is to apply a sine wave with a constant amplitude and gradually increase the frequency. As the frequency increases, the measured amplitude will eventually start to drop. When the measured amplitude reaches 70% of the original amplitude, we have reached the -3 decibels point. This frequency is called the pole frequency, and it defines the bandwidth of the oscilloscope. The bandwidth of the scope directly limits how fast an edge it can resolve in the time domain. There is a simple and very useful rule of thumb that connects rise time and bandwidth. Rise time equals 0.35 divided by bandwidth. As an example, if an oscilloscope is rated at 1 gigahertz, the shortest rise time it can measure is approximately 350 picoseconds. This has an important implication. If the actual signal has a rise time of 100 picoseconds, the scope will not show that true rise time. Instead, the scope will display a slower edge of roughly 350 picoseconds. What we see on the screen is limited by the measurement system, not just by the signal itself. This is why it is critical to always be aware of the bandwidth of your signal, the bandwidth of your oscilloscope, and the shortest rise time your measurement setup can accurately resolve. Understanding these limitations helps avoid incorrect conclusions and is a key part of making reliable signal integrity measurements.